Look around you for a moment. Your phone, your laptop, your television, your car, even your refrigerator, almost every modern device relies on tiny electronic components called semiconductor chips. These chips power the digital world. They process information, run software, and make modern technology possible. But something surprising lies behind these everyday devices. Most of the chips used in American products are not actually made in the United States. For decades, the global semiconductor industry has been dominated by factories located thousands of miles away in Asia. Countries like Taiwan, South Korea, and China have become the center of chip manufacturing, producing the vast majority of the world's advanced semiconductors. That global system worked efficiently for many years. But rising geopolitical tensions, particularly between the United States and China, have exposed just how fragile this supply chain really is. Suddenly, one question has become urgent for Washington and for American technology companies. What happens if access to those overseas chip factories is disrupted? The answer could affect the entire global economy. This growing concern has triggered a massive effort to bring semiconductor manufacturing back to the United States, a process often called reshoring. And one of the companies leading this shift is Apple, the world's largest buyer of semiconductor chips. Apple recently announced plans to invest hundreds of billions of dollars in the United States over the coming years. The goal is not just to build new products, but to help rebuild an entire technology supply chain inside the country. To understand how that process works, the journey begins at the very start of chip production, where the raw material for semiconductors is created. The foundation of every chip begins with something surprisingly simple: sand. Inside certain mountains in North Carolina lies some of the purest quartz sand on Earth. That sand is transformed into silicon, the most important material used in semiconductor manufacturing. But turning sand into the foundation of a microchip requires an extraordinary industrial process. At a specialized facility operated by Global Wafers, raw silicon is melted inside towering furnaces that reach temperatures of more than 2,500 degrees Fahrenheit. Inside these machines, molten silicon slowly forms into a large crystal structure while rotating inside the furnace. The result is a massive cylinder of solid silicon known as an ingot. These ingots can stretch several feet long and weigh hundreds of pounds. Despite their size, they are only the beginning of the chip manufacturing journey. The ingot is carefully sliced into extremely thin circular discs known as silicon wafers. Each wafer is polished until it becomes perfectly smooth and flawless, creating the blank canvas on which semiconductor chips will eventually be built. Even producing these blank wafers is an extremely demanding process. Tiny imperfections can ruin the entire production run. The purity requirements are so strict that factories may take months to perfect each step of the manufacturing line. And when it comes to demanding quality standards, few companies push suppliers harder than Apple. Every Apple product relies on multiple chips. An iPhone alone can contain more than 30 different semiconductor components, many of them incredibly complex. Because Apple produces hundreds of millions of devices every year, even small improvements in chip supply can have enormous impact. But there is a larger issue behind Apple's push to source more components domestically. Today, most of the world's advanced chips are manufactured in Taiwan, an island located just off the coast of mainland China. The company responsible for producing many of those chips is Taiwan Semiconductor Manufacturing Company, better known as TSMC. It is the largest and most advanced chip manufacturer on Earth. The problem is that Taiwan sits in the middle of rising geopolitical tensions. China considers Taiwan part of its territory and has repeatedly warned that it may one day seek to bring the island under its control. At the same time, Taiwan lies in a region prone to earthquakes and natural disasters. For companies that depend on a steady supply of semiconductors, concentrating so much production in one location creates enormous risk. To reduce that risk, TSMC has begun building a massive semiconductor manufacturing complex in the United States. Located in the Arizona desert, the site spans more than 1,000 acres and represents one of the largest industrial construction projects in the country. When completed, the project could cost more than $165 billion. Inside these fabrication plants, commonly known as fabs, blank silicon wafers are transformed into fully functional semiconductor chips. The process is one of the most complex manufacturing operations ever developed by humans. Using machines that cost hundreds of millions of dollars, engineers etch microscopic circuits onto the surface of each wafer. These circuits contain billions of tiny switches called transistors. Each transistor acts like a microscopic gate that controls the flow of electrical signals. Modern chips contain billions, sometimes even trillions, of these transistors packed into areas smaller than a fingernail. Building them requires engineering at the atomic scale. Yet even with enormous investment, building new semiconductor factories takes time. The Arizona facility currently operates only one active fabrication plant, while several others are still under construction. And even when fully operational, the chips produced there will initially be less advanced than the cutting-edge chips still made in Taiwan. That gap exists because the technology required to produce the world's most advanced chips is extraordinarily difficult to replicate. At the heart of that technology is a remarkable machine produced by a Dutch company called asml. These machines are responsible for one of the most critical steps in chip production: lithography. Lithography works by projecting patterns of light onto silicon wafers, effectively printing the tiny circuits that form semiconductor chips. But modern chips are so small that traditional light sources are no longer precise enough. asml solved this problem using an astonishing technology known as extreme ultraviolet lithography. Inside these machines, powerful lasers fire at droplets of molten tin, creating a special wavelength of ultraviolet light that does not naturally occur on Earth. That light is then directed through an intricate system of mirrors and lenses, allowing it to carve incredibly precise patterns onto the wafer surface. Each of these machines can cost anywhere between $100 million and $400 million. And because chip designs contain many layers of circuitry, the lithography process must be repeated again and again with extreme precision. If a single layer is misaligned by even a few nanometers, the entire wafer could be ruined. Once the chips are created, the final stage of the supply chain begins: assembly. At facilities operated by manufacturing partners such as Foxconn, chips are installed into finished products. Inside these assembly plants, workers and automated systems combine circuit boards, processors, memory components, and other electronics into completed devices. In the United States, some of these facilities are now expanding to assemble Apple products domestically. In Texas, for example, a growing manufacturing site is preparing to produce Mac Mini computers. While this represents only a small portion of Apple's overall production, it demonstrates how the company is slowly shifting parts of its supply chain closer to home. Still, the scale of global manufacturing remains enormous. Apple sells roughly 240 million iPhones every year. By comparison, the total number of Mac Mini computers sold annually is less than 1 million. This illustrates the challenge facing efforts to rebuild semiconductor manufacturing in the United States. The factories being built today represent only the first steps in a much larger transformation. For decades, Asia has been the center of global chip production, supported by massive infrastructure, specialized workforces, and highly optimized supply chains. Recreating that ecosystem in the United States will take years, possibly decades. But as technology becomes increasingly central to national security, economic growth, and global competition, the race to control semiconductor manufacturing has become one of the most important industrial battles of the 21st century. The chips inside our devices may be invisible, but the global struggle to build them is shaping the future of technology, economics, and geopolitics. And that race is only just beginning.